Okay, hello everyone, and hello to anyone watching this after the fact on YouTube. Welcome to the Singularity CE community call for March 2023. This one will be relatively short, I think. We'll have a bit of a recap of the 3.11 release, which happened last month, but we've already gone through the features there and looked at stuff in depth in the past, so we won't dwell on it too much. We do have a topic to kind of bring up and kick off conversation about. That's integration of the container device interface into Singularity, and then we'll get on to any other business, any other updates and so on. So I'll start off just giving an overview of the 3.11 release. That went out on the 10th of February, and we've been through the change log with all the new features and functionalities before and talked about the changes there. If you've been using 3.11 and you've hit any issues, please do let us know via Slack or the GitHub issues or anywhere else you can find us. We've had a few bug reports since the release, and some things that have fixed include these points here. So only the first one is actually related to the 3.11 release. It's a regression where for people using the NVC CLI flag, to set up GPUs using the NVIDIA container CLI tool. When you do this, Singularity has to start up with a writable tempfs, and the implied option to enable that wasn't working properly. So it can kind of throw up an error if you don't add that flag manually. That's going to be fixed and back to how it should be working in the next patch release. The other things that are waiting to come out in the first patch release, the other points here, aren't specific to 3.11, but they're bugs which have been reported since the release. So there's one related to a false error when you request a certain network under the fake root mode. There's an issue that someone reported where their unsquashfs was using libraries not in default paths on the host. And we had some code that should have taken care of this, but it wasn't passing something through properly. So we fixed that for the next patch release. Our instance stats that was added in 3.11 wasn't correctly showing a memory limit as the maximum amount of memory a container could use when one was applied. So that's updated now. And then the bottom point here is that when you're using NVIDIA or AMD ROCm GPUs without the NVC CLI option, under some circumstances, you can end up on your host with multiple versions of the same library installed. So you might have a version 1 EGL library that's provided by your Linux distribution, and in a different place, one that's provided by your graphics card vendor. And the way that Singularity was handling this up until now, it could randomly choose between the two options there if they were named exactly the same, but in two different places in the file system. Not a lot of people hit issues because this is relatively rare. It only affects certain libraries if you've got your GPU drivers and things installed in certain ways. But we've modified it so that the code will reliably take the first version of the given library that appears in the output of the LD config tool with the P flag. So it'll just make sure we always bind into the container the version which has the highest priority in the system configuration. So that's what we've got kind of waiting to come out in the first patch release. As I said, please do report any issues and things. Do we have any questions at all about the 3.11 release or anything that's waiting to come out? Okay then. Let's move on to talk a little bit about the container device interface. So it says here, future of GPU support. Now, in Singularity, we've offered support for running containers using GPUs from quite early on in the development of Singularity, through a method where we have a file that lists all the libraries that low-level libraries a GPU driver install on the host provides, and we'll try and bind those in and make sure the device is available as well in the container. So that's what the NV flag does, and what the ROCm flag does for AMD GPUs. Just kind of naively looks for a bunch of libraries in those lists, binds them in, and sets paths and things so that in the container, workloads can find those libraries from the host, so that everything lines up with the driver version on the host, and hopefully your GPU program runs. That works quite well in most situations. And the majority of people who are running Singularity today use that simple binding. Later on, for NVIDIA GPUs, we started to offer the ability to use NVIDIA's own tooling to bind libraries and set up the GPU in a container. And that's the NVC CLI option that came up a minute ago. So there, if you use that, Singularity is asking an NVIDIA tool to actually do all the GPU related setup of the container. Singularity itself isn't binding anything, the tooling is. And NVIDIA's tooling allows you to do things like mask certain GPUs on a multi-GPU system. So only maybe 1 out of 3 GPUs which are in your host go into the container. It also allows you to kind of limit the functionality that's exposed in the container. Only CUDA GPU compute functionality, or only OpenGL functionality, and so on. So it's a bit more flexible than the naive binding approach we've always had, but it requires external tooling that we call out to. And there's an issue where it doesn't quite work in every single flow we support with fake root and so on. The way things are going now is away from these tools like the NVIDIA library and CLI, towards something called the container device interface. So if I hop over to the GitHub repository for this, we'll see that there's a what is CDI section here, and it's saying it's a specification for container runtimes to support third-party devices, right? So it's meant to be a vendor neutral thing, and they've come up with a standard way of saying this is a device on the system. You should expose it into a container according to the details that are provided in a specification file. And it's up to each vendor, so NVIDIA or AMD or Intel, to have a way of providing the necessary information so that a container runtime can look at a spec file and perform binds of libraries, device files, set any environment variables and things in a vendor neutral manner, rather than having to have kind of calling out to separate tooling for each GPU vendor, or implementing its own sort of naive bindings like Singularity does. So there's quite a bit of information here. They cover why CDI is needed, roughly how it works, and how you can configure it on a system. And this is probably not that interesting to the majority of users on HPC systems, because commonly GPU drivers and things are set up by an administrator, and some of the lower level stuff here won't be really relevant for most people. But if you are an administrator and you're interested in looking at the spec, then there's also a full kind of document here that goes through it, and you can go down into the detail and see an example here which shows you basically how the CDI file is going to instruct a container runtime to make a device available and mount in libraries or run hooks and things like that. So CDI has come up in development discussion in Singularity very recently again, because of two things. So the first one is that we're pushing down a road with Singularity 4.0 toward greater OCI compatibility and running OCI containers from an OCI on disk format natively using a low-level runtime program, runC or crun. Now, in the OCI world, CDI can be implemented quite easily by just taking an OCI runtime specification, which you kind of feed to runC or crun when you ask them to start a container, and using some CDI libraries to modify that specification according to the CDI spec for any device the user requests. So it's quite easy for us to think about adding CDI support to the new OCI mode of Singularity. So we have a couple of issues open, and the first one of these here is about that, adding CDI device support to OCI mode, so that instead of just saying --nv or --rockem, you would say --device and give the CDI name of the device you want in the container, and then that's going to bring your NVIDIA GPU or your Intel GPU or whatever into the container. And the Intel GPU point there is important. Up till now, we've had to do different things for different vendors. This will allow us to just support the vendor neutral standard for bringing things in to a container. So this part is going forward, definitely. And we're going to try and get this in place by the next meeting so we can demonstrate it and invite someone from NVIDIA to join us, who's been working very heavily in the CDI world and with other vendors in there, actually kind of implementing the standard and getting it into other runtimes like Podman and so on. So this bit you'll see more of shortly. The other area we kind of want to raise today is to consider adding CDI support to the native runtime of Singularity. So if you're not using the --OCI mode, if you're not really interested in using native OCI containers and the stuff that's being added in Singularity 4.0, we're trying to gauge whether you're interested in CDI support for the existing runtime. So if you have your existing Singularity native CIF containers and you need to use GPUs with them, is there a benefit to us making CDI available? Now, we have these approaches that exist using --nv and --rockem. We have --nvc CLI to use NVIDIA's tooling. Should we add --device in order to support CDI as well? There's an issue here, and what I kind of invite people to do is, if you're using GPUs with Singularity, take a look at it, and it goes through some of the background and also what some benefit might be of adding CDI, and also considerations of what some downsides might be, whether this is really needed on the majority of systems, for questioning whether the existing NV and ROCm flags are enough right now. Like I said, we'll be hoping to present the OCI portion of the CDI stuff in the next call, and invite Evan from NVIDIA to come along and talk about CDI some more. And then we can hopefully have a bit of a discussion and solicit more community input on whether it's worth adding this to the native runtime in addition to the OCI mode. Okay, I've talked rather a lot about this. Are there any questions, or I don't know, Adam, whether you had anything to add on this?
I guess maybe one kind of open question, but just to get it out there in front of everyone. So you've talked about NVIDIA and Intel for the CDI approach. We obviously have the --ROCm flag for AMD. In both of those cases, kind of with 4.0 and with the Singularity engine, what's the plan for AMD support? Is it moving towards CDI as well, or kind of leveraging the current approach there?
I guess we're kind of hoping it's moving towards CDI, right? So this standard is being adopted, but we haven't really seen a great deal of evidence that AMD is kind of switching to that. On Docker and OCI runtimes, what AMD generally suggests is that they're providing ROCm containers which are bundling all the libraries into the container, and then they are just making sure the right commands are in place when you do a Docker run to bind in the device files, giving access to the graphics card. So there's a bit of a kind of less developed way of handling this for AMD graphics cards in general. So we'll see how that goes. I think it's fair to say that at present we won't be able to remove that --ROCm because there aren't really the vendor isn't really the vendor tooling in place to get the CDI files which would replace it. But hopefully AMD will pick up CDI and we'll start seeing that become available to use.
So DT, with the dual engine support inside Singularity, the native Singularity runtime, and the either run C or C run, and the conversation about moving towards CDI, if that is developed for native Singularity, would you consider leaving the legacy modes in there for infrastructure that doesn't want to make the changes or adopt or slow to adopt the new approach?
So we were able to chat about this a little with some of the folks from NVIDIA and someone from Intel, and there is kind of a way to preserve. If we go down CDI route in the native runtime, we can use our some of our native binding code, the bit which discovers libraries and devices. And then we could generate CDI from that and feed it into CDI code to bind things. And that would really kind of allow us to reduce the number of different ways we bind GPUs, but at a low level, but maintain the ability to bind a GPU in if you don't have any CDI files provided by tooling or that you've set up. So that's something to explore. It'd be interesting to kind of get a feel for whether people are very open to configuring their systems so that they have CDI specifications available on the host, or whether that's really important to maintain that sort of no extra configuration NV mode.
Thank you.
Okay, any other questions on that? like we kind of hinted, Adam, and I mentioned, this is something we're really looking for input on, and hope people can join us in the next call and actually see the OCI bit working, and then we can talk more about where we go from there. Okay, other than that, the development work at the moment is really focusing around identifying and fixing bugs from the 3.11.0 release. So we're doing that, and there isn't a great deal of new feature work to talk about right now. If you do want to see what we'll be moving on to, though, in the next couple of weeks, the roadmap has been updated at the link that's on these notes, so you can see the 4.0 features that will start working to tick off in the near future. The only other thing to mention, I think, at this point is we're at Sylabs lucky to welcome Omer on board. He's on the call, but I'll let him stay quiet if he wants. He's started to make contributions to SingularityCE, and you'll see him popping up in the online spaces and things in the near future. So welcome to Omer. Have we got anything else at all before we call it? And I take this one as a fairly short meeting this time.
Last question, DT, in terms of 3.11 in Apple or any CE release for that matter, is there an expected cadence for release of CE and then it finding its way into Apple?
Yes. Right, so where were we? Okay, so it was 2nd of Feb was our last call, and then we released on the 10th of Feb the 3.11, and then I went through for our Apple packaging about a week after that and started submitting into Apple updates for 3.11. So you can see here now that those have actually made it through into Apple 7, 8, and 9. It takes about a week for the updates. Yeah, I suppose the cadence is that we'll have Apple things out within a week or two from the SingularityCE release through GitHub, the source release, and the packages we host on GitHub. And then probably for patch releases, we're looking, as we have done in the past, every 4 to 6 weeks on average, we're putting out something with bug fixes. So obviously those will roll down to Apple in the same kind of 1 or 2 weeks after the source release that this 3.11 did. One thing important actually here, while I stare at it, this releases overview is showing that we've got 3.11.0 in everywhere in Fedora and Apple except Fedora 38, right? Fedora 38 is the next release of Fedora, and what they've done is they branched it off Rawhide, which is the development branch, and it's now in a freeze. So this is why the 3.11 hasn't been pushed up here, because it's in a freeze where updates are only dragged in at this point if they fix release bugs. Once Fedora 38 is out, then this will catch up and we'll have 3.11 in Fedora 38.
Thank you.
Anything else at all? All right, well, we'll say goodbye, I guess, for this month. Next month, we'll have a bit more to show and talk about. So I hope to see you then. Thanks if you're joining live or watching this on YouTube, and please do reach out if you have any questions about anything we've talked about via Slack, the mailing list, or any other way you know to get a hold of us.